So today our problem is a skateboarder sped down a ramp and launched into the air at an angle of 73 degrees from the horizontal. He traveled 1.3 meters above the end of the ramp. Determine his launch speed and how far he traveled horizontally. So to do this, let's discuss what we already know. So we know that horizontally, we don't know its displacement. That's what we want to find. We don't know the velocity initial or the velocity final, but we do know they will be equal. We do know that the acceleration, because the velocity initial and velocity final is equal, is 0 meters per second squared. And we don't know the time. For vertical, we do know the displacement. It's 1.3 meters. Again, we don't know the velocity initial or the velocity final for the whole trip. We do know that the acceleration is negative 9.8 meters per second squared. And we don't know the time. But we do know that the horizontal and the vertical times will be equal. So first, let's look at just half of the trip. And we can look at the vertical component to try to figure out t. So I'm just going to leave this here for now. So using this formula, displacement equals velocity initial times time plus 1/2 acceleration t squared, we can transform it to find t. Looking at the second half of the trip, we can call our velocity initial, or the top of the peak, 0 meters per second. And we don't know our velocity final, but we don't need it for this equation. And we also know our acceleration, as stated before, was negative 9.8 meters per second squared. Thus, we can rearrange it this way. This cancels out because velocity initial is 0. And let's use that equation. So t equals the square root of negative 1.3 meters. Our displacement, it's negative because we're only looking at the second half of the trip. This is his start, this is his final. He traveled downwards 1.3 meters. Divided by 1/2, which divided by 1/2 really means there's a 2 in the numerator and a 1 in the denominator. And our acceleration. Our meters cancel out. And then because it's a square root, that seconds squared will just become seconds. So we get 0.364 seconds. So let's just take notice that this is only for half of the flight. Only the second half, or we can even say only the first half. That just gives us time for half of the flight. We would need to multiply it by 2 to get the whole trip. So if we multiply this by 2, our full trip time is 0.728. So right now, we can fill in our time. We found that it was 0.728 seconds for the whole trip. Now that we know our time, we can look at half the trip again. This time we'll just look at the first half, and we can use this formula. Acceleration equals velocity final minus velocity initial divided by time. So we can say that our velocity final is 0 meters per second at the peak, and we don't know our velocity initial, but we're going to solve for that. And we do know our acceleration, obviously, is still negative 9.8 meters per second squared, because we're still looking at the vertical. So let's fill this out. We can say that negative is a negative 1 times this stuff. Acceleration is negative 9.8 meters per second squared. And t. So what t do you think we'll use? Will we use our half trip or our full trip time? Because we're looking at only half the trip, we're only going to use half the trip's time. So we're going to use the 0.364 seconds. So those cancel out. So we get 3.567 meters per second. Okay, so that's our next part. So we now know our velocity initial for vertical is 3.567 meters per second. Now that we know all this, we can use SOHCAHTOA. So just looking at our triangle, this is for our initial velocities only. This is not for our whole trip, because when he jumps off the ramp, he doesn't travel like a triangle. He travels like an arc. But we can use this for the initial velocities. So we know that that is 73 degrees. We know our initial vertical velocity, but we don't know our horizontal the horizontal velocity initial, or our launch speed. So to do this, let's find A first. So that is the tangent of 73 degrees equals 3.567 over A, because tangent is opposite over adjacent. So 3.567 divided by tan of 73 equals A, and that gives us 1.09 meters per second. So that is our horizontal velocity initial. Now let's find our launch speed, because that was part of our question. So we can do sine of 73 equals 3.567 meters per second divided by, I just called it C, because A squared plus B squared equals C squared. So if we just move it around and solve, we end up getting 3.73 meters per second. So that is our launch speed, his initial velocity jumping off the ramp. So the launch speed was, we'll write it in purple, 3.73 meters per second. So we solved half of our equation, but we still need the horizontal displacement. So what equation can we use for that? We can use our horizontal displacement equation. Displacement equals velocity initial times time plus 1/2 acceleration t squared. Because our acceleration, going way back to over here, is 0, we can just kind of cancel out that part, because 0 times anything is 0. So we just get velocity initial times time. So doing that, our displacement is our velocity initial, which we just found, times our time. So again, we have a little bit of an issue. Do we need to use our full time, or do we need to use our half trip's time? Well, because we want to find the whole trip's horizontal distance from start to finish, we need to use our whole time that he was in the air. So for this problem, this area, we're going to use 0.728 seconds. Those cancel, and we get 0.794 meters. So we know his horizontal displacement is 0.794 meters. So now you can see we solved our problem. His launch speed was 3.73 meters per second, and the horizontal displacement is 0.794 meters.